Hello everybody, and thank you so much for coming to my little talk about how hacking works. I can see that some of you are still making it into the room, but I'm going to continue nonetheless because we have a short amount of time. Because this is actually a 2-day workshop that I have to compress into 45 minutes of speaking, so let's see how this goes. Who am I? So my name is Espen Sande Larsen. I'm a developer, I've been an architect, I've also been a hacker. I've also been a professional musician. I've released music, I've traveled, held concerts, played in bands and all that stuff. I have 3 kids, which I adore. When I don't spend time doing music and with my family, I spend all my downtime doing technology stuff. And now my microphone is working again. Awesome. I do everything technology related that I find interesting, everything from programming, tinkering with hardware and software and all that good stuff. And I also really enjoy drinking beer and doing mischievous stuff. So if you see me at the Sky Bar later, buy me a beer and we'll have an interesting conversation. And I also work for this little thing called DNB Bank up in Norway. I know nothing about banking or finance. My wallet will attest to that. But I do know a lot about technology, which is why I work at the research division called New Tech Lab. Which also sends me over to this thing where I have to have this disclaimer since I work for a big bank. This is yada, yada, yada. Whatever I'm about to say is nothing that the bank says, it's what I say, basically. And the previous slide is missing one key component that you usually see on these types of slides, and some of you may have noticed there was nothing about education or academics on that slide. And that is because I don't have any. I didn't go to school, I didn't get a PhD, I didn't do a thesis or anything like that. I just dropped out of school and started working when I was 16, and because I discovered something at 16 that people were willing to pay me money for 2 things. One was playing and performing music, and the other one was writing software. And I thought, well, that's a scam. I'll write software and get money. And I've been doing that ever since. And then you may ask yourself, how on earth does a 16-year-old brat get paid for doing software when he has no academic background? Well, that all started with a drug deal back in the 80s, where my big brother brought this thing into my house. Because he had traded some drugs for this computer, and he got it into the living room, and we fired it up, and we didn't understand a thing. Because when you buy a black market computer in a drug deal, you don't get the best support package. You didn't get like a helpline or a documentation or anything like that. And I would spend the next couple of years trying to figure out how this thing worked. And because some of you have seen this before, some of you are wondering what the hell is that weird keyboard thing. This is a Commodore 64. It's an all-in-one computer. It has an 8-bit CPU and a 16-bit address bus, and that's about it. The rest you have to figure out by yourself by programming it. In order to make it to do stuff, you actually have to program it. It has a programming language embedded, it's called BASIC, but BASIC back then was, the difference between assembly programming that thing and programming that thing in BASIC is basically just you get 1 extra syllable in your mnemonics, because you still have to know how the hardware was laid out. So now we know who I am and how I approach all of these technology things. Let's talk about what hacking is, because that's what we're all here to figure out. So what is hacking? But why ask the question? Let's have Hollywood define it for us, because they spend millions of dollars making movies and television shows. They probably do research, right? So here's a TV show. It's called NCIS, and we're about to see hacking in progress. So let's see how that looks like.
No way. Yeah. I'm getting hacked.
Of course, kid.
That's how you know you're getting hacked. You get like 2 million pop-ups.
They've already burned through the NCIS public firewall.
Well, isolate the node
and how do you defend against a hack? Well, you get on your keyboard. And what's better than 1 defender? That's 2 defenders on the same keyboard. Because that's how keyboards work.
I can't. It's a point attack. He or she is only going
and of course, the solution to this comes from the non-technical person, the management.
Video game?
No, Tony, we're getting hacked.
And some guy is just eating a sandwich for some reason.
Can't stop him. Do something with
And the solution is pretty simple.
Where'd it go, Abby?
I didn't do anything. I thought you did.
No.
What do you think it is? Well, you just unplug the freaking computer, because all essential files and the things the hackers were after was residing on that single terminal in this entire government agency. That's how things work. How about another TV show? It's called CSI. Maybe they get this thing right.
For weeks, I've been investigating the Cabby killer murders with a certain morbid fascination.
This is in real time.
I'll create a GUI interface using Visual Basic. See if I can track an IP address.
Yeah. I'll create a GUI interface using Visual Basic to see if I can find an IP address. I can't even comment on that because that's just silly. How about a movie that's called Hackers? Surely they did some research. Well, by the looks of that keyboard, I suspect that maybe they didn't. So this is a movie about hackers attacking a corporation, and the corporation has to defend. So let's see how they do it. So they send the virus.
In the database.
What's happening?
That's the virus. It eats memory like Pac-Man.
What do I do?
Type cookie, you idiot. I'll head him
Yeah,
off
that's
to
how we
pass.
stop it. You just type cookie.
We have a zero bug attacking all login and overlay files.
Run antivirus. Give me a systems display.
That's how your interface is like.
6
You have this 3D thing where you can blast the hackers with lasers.
and 1 for 6.
Die, dickweeds.
Yeah.
A rabbit is in the administration system.
Send a flu shot.
Rabbit, flu shot, someone talk to me.
Yeah, that's not a thing.
Replicates till it overloads a file, then it spreads like cancer.
Cancer?
Yeah, and we all got these circular, non-standard keyboards, right? Yeah, that's silly. How about a show about an actual hacker? They had to do some research because it's about reality, right? Well, this is my favorite nonsensical hacking demonstration in television and movie history ever. Look at this. So there's, just to preface it, there's malware on a plane, and the hacker has to patch the plane by chasing after the plane in a Ferrari. Because the only way to patch the plane is to get a member of the flight crew to go down on the landing gear with an Ethernet cable to patch the plane. For some reason, the defenders had to patch it by directly connecting to the plane, but the attackers could remotely access the plane, so I don't know why. And of course, patching takes time. We all know Windows Update, so you just have to stretch. Yeah. I actually tried to get my boss to buy me a Ferrari in case I needed to patch the plane, but sadly that purchase order never went through. Now, this is all nonsense, but let's talk about what hacking really is, because it used to mean something different, at least back when I got started out. Because back in the day, hackers and hacking was something, it meant that you tinker with stuff and try to make things work differently than what it was intended to do. So you were tinkering with software and hardware, and you try to make things do more things that it could do. One of my favorite examples of this is the Apple II's color circuit, because it doesn't have a color video chip. But Steve Wozniak figured out how to manipulate the composite signal to make the cathode ray gun misalign when it hit the phosphorus cells, and that enabled him to make some colors. And that's what essentially old school hacking was. What we refer to as hacking today was originally called phreaking, with a PH, and that's because they were freaks and they used phones. Because back in the 80s and 90s, if you wanted to talk to a computer remotely, you had to call it up on the phone and say, hey, computer, I want to use you. And things have progressed since then. But basically, the term hacking we use today, it basically means this one thing. We're trying to exploit systems through their vulnerabilities. And this talk can take a couple of different turns based on the audience, and I'm going to do an informal poll of you people. So by raise of hands, because I can see you, so how many of you are programmers, coders, developers, or whatever they call themselves these days? Well, that's a great chunk. How many of you are tech leads, architects, solution principals? You work in PowerPoint, not necessarily write code and whiteboards. Awesome, a couple of you. How about security engineers, pen testers, or actual hackers? Well, the day is young. I will turn you into hackers over the course of this talk. And how many of you are something completely different? You're like management, scrum masters, project managers. A couple of brave souls, awesome. Great. Now that I know that, let's talk about the different kinds of hackers, because you can identify their motivations by the color of hats they wear. Because they wear these hats, which is kind of beneficial, because then you can look into a room and can say, well, you're a black hat hacker, you're a red hat hacker, I know your motivation now. Now, this is just a way to categorize them based on their motivations. So the black hats, they are the malicious ones, they do bad stuff. White hats, they do ethical stuff. Gray hats, they are kind of in between. They may try to exploit the system they not necessarily have permission to do, but they gamble that they may be rewarded for their efforts if they disclose that to the company and not get litigated. Then we have the green hats. These are the new hackers who have started their hacker journey and started learning, which is what I hope to turn you into over the course of this talk. We have the red hats. They hack other hackers and hunt down hacker organization. And we have the blue hats, which are hackers that are invited by companies that produce like software or solutions to try and hack their systems prior to releasing them. For instance, Microsoft has a long tradition of hosting blue hat events where they will try to exploit new versions of Windows or Office or any other Microsoft product prior to releasing it. So now that we know the hackers, let's talk about why hacks actually happen, because they do. And why? Well, it's because we are developers and we are human and we make mistakes. And those mistakes may not necessarily be something we do on purpose, but software systems can be these complex, gigantic monsters that are hard to tame, and they may have millions and millions of lines of code, and they have millions and millions of dependencies that we may not know everything about. And hackers exploit that little detail that you didn't know was even there, and that's where the devil is. And this is actually happening on an increased scale these days, because we tend to love other people's code these days like it's the best thing in the world. We kind of stopped writing our own code, but we are using other people's code. And sometimes we get so married to our tools that we like to use that tool for whatever purpose we think we can. It's kind of like if you have a hammer, but you need a cement mixer, you will still stir the cement with the hammer because it's so familiar to you. And I know this by experience, because I was actually hacked, and I was really hacked. And this cinnamon bun picture is going to make sense in a little bit. Because back some years ago, when I was a young developer, I got the opportunity to be a CTO in a tech startup, which was pretty exciting. They wanted to build this advertising platform for online newspapers, and they wanted to have this to be global across Europe, the entire world. And we were going to have the ad spaces were going to be like a channel where we can send ads, and we can have interactive ads where the users could win prizes by playing games, and we can measure engagement and all that nice stuff. The problem when you're a CTO in a startup, you're also the tech lead, you're also the principal architect, and you're also the lead programmer. So I had to build this entire system by myself from the loose abstract idea that we were going to take over the advertising world. This is also before there were any clouds, so I actually had to set up this distributed real-time system by traveling across the world, setting up data centers, servers, and patching everything together and making sure that everything worked. And when I had built this nice distributed system, there was one thing left, and that was the client side. How on earth were we going to serve these games to the people? Well, there was only one technology available at the moment that could do that, and that's called Flash. How many of you know what Flash is? Okay. For those of you who don't, here's a crash course in Flash. This is your IDE. It's called Flash. It was made by Macromedia, later acquired by Adobe. You can see we have a code window. The code was kind of like JavaScript, but it was strongly typed. It was kind of strange. But you also see on the left side, we have drawing tools and we have this timeline. So that's an indication that software and secure systems is not what this thing was intended to do. And that was correct, and I learned that the hard way. I thought this was fine because it compiled into binary format. The thing was that binary format was sent to the client, and it was easy to reverse engineer. And that's what happened at a Swedish university. A student did actually reverse engineer my code. And in that code, that student found the backend code that would generate the prize tickets. And we had this campaign where you can play this game. You have to kill flies, and you will get a ticket where you can get a cinnamon bun in a Swedish retailer store. So I got the call early one morning from my CEO, furious on the other side of the line, saying that one student had picked up 73 cinnamon buns in one single day. And my immediate response, that's a lot of cinnamon buns. That person really likes cinnamon buns. Well, we had the board meeting. I had to stand there and say, I'm sorry, it's all my fault. It's never going to happen again. I don't know how to solve it, but we're going to solve it. And everybody was yelling at me, and I got kind of sick of getting yelled at. So I thought, well, I'm going to have to spin this into something positive. So I said, no. We're going to go to Sweden. You, CEO, you're going to take a big case of cinnamon buns and find this student. You're going to bring a newspaper. And you're going to make a story how we thank this individual for finding the security flaw. So we got a 2-page spread in the biggest newspaper in Sweden with the student with cinnamon buns and the CEO going like this. So that kind of was the impromptu bug bounty program that I came up with. We solved the problem, and it got fixed. And I actually held this talk a couple of months back, and this guy came to me afterwards and said, hey, you're the cinnamon guy. And I said, yes, I'm the cinnamon guy. Well, I wrote my PhD thesis on your solution because it was a great example of what not to do. And now that is part of the textbooks in the innovation master study in Sweden. So I literally have the textbook example of what not to do, which I got a big kick out of. Thought that was funny. So my colossal failure will now teach generations for generations to come what not to do. So how can we prevent these things from happening? And that is, if we get into the mindset of thinking like a hacker, maybe we can actually start to probing our own systems to see what happens if we do these kinds of things. And one great way of learning how to do hacking is something called CTFs. How many of you are familiar with CTFs? Okay, a couple of you. I will let Elliot from the excellent TV show Mr. Robot, the one that actually gets hacking right, define it for you.
A CTF tournament. Capture the flag. It's like the Hacker Olympics. Teams around the world compete to solve challenges, reverse engineering, protocol exploitation, forensics. The entire city suffering an energy crisis while they're here exercising their inner anarchy.
Yeah. So it's a capture the flag contest where you can exercise your inner anarchy. I think that's beautiful. So CTFs are that. They're capture the flag tournaments where you have to solve these little tasks. And you do so by actually performing hacking or something hacking related. And it's a great gamified way to learn these adversarial techniques and mindset. And we have hosted a couple of them in DMB, and what I've seen is that it's an incredible catalyst for learning. And the thing is that when you start thinking like this, you kind of change your mindset a bit, so you're thinking differently about your solutions and your problems. And they work by you solving these challenges, as they are called, where you have this little thing that's encapsulate one aspect or one technique of hacking. And when you do this, you get some cool coffee machine water cooler conversations in your organization when this thing is going on. And my favorite email in DNB Bank that I ever got was from a lawyer in the legal department who sent me a letter of apology because this person had performed a SQL injection attack on one of the challenges and by accident had deleted the entire database. So this person wanted to say sorry for that. And I think when you're a bank and your lawyers in legal are performing SQL injection attacks, you're doing something right. That's pretty cool. And it's actually really fun just to be the villain or the bad guy for once. These challenges come in different categories. They are, the categories are kind of there to set your way of thinking into how you're supposed to solve these challenges. So we have like crypto, that's not Bitcoin, it's about encryption, where you break codes. You have stego, it's kind of like crypto, but you're hiding something inside something else. It could be like an image inside a binary file or something like that. We have forensics, where you actually have to do some data digging, data mining, where you have to extract something from log files, a file system, or something like that. And now we're getting into the things that are akin to real hacking. We have reverse engineering, where you have to figure out how a piece of software works and what's the vulnerability and how to exploit it. And we have something that's usually called vulnerabilities, where it's you exploit some kind of known vulnerability in something third party, meaning other people's code. And then we have usually a category that's web and web only, where you do only web stuff. And then we have the creme de la creme of everything, that's called pawning, where you actually have to take over a remote service and you have to gain arbitrary code execution or a shell or something like that. When you do host CTFs, it's customary to list some tools if you have beginners, so they know what to do and where to start. And here are some tools. This is a non-exhaustive list. I'm not going to go through all of them, because I want to have some time for demos, but there are some nice tools. We're going to see them in the demo section. If you want to take a picture, that's now. And they do different things. Some of these are hacking tools, some of them are just system tools that you can use to get information and stuff like that. So, let's get into some demos. Let's see if I can do this. Let's see what it's like to solve some of these challenges. Okay, we have to do this. And my microphone is doing that. Let's see. Can you see my screen? Great. Okay, before we start, how many of you work in managed languages, meaning that you compile into some intermediate that's run by a runtime, or it's run in an interpreter like JavaScript, Python, PHP, Java, .NET, C#? How many? Okay. How many of you work in native things, meaning you compile to binary code that's actually machine code? A couple, okay, cool. So for those of you who work in managed languages, there's something underneath the virtual machine. That's the actual machine. It's not going to be that technical, but it might look a bit complicated. But we have one challenge here. It's called ROPME. Any of you know what ROPing is? Okay, ROP stands for return-oriented programming, and it's all about executing the control flow of a program. So we have this binary. It's provided to us by the task. It's an ELF executable, meaning it's a Linux binary that we can run. And if I run it, whoop, I have the wrong keyboard. It says, yo, enter my name. And it says, thank you for running this binary, which is uneventful. But let's see. I'm going to use GDB to illustrate this principle, because normally what you would do, you would get a copy of the binary, and you would do this to develop your exploit. And then you would have to exploit something running remotely. But now, for the sake of illustration, I'm just going to run this using the GNU debugger, which is a great tool. So here we can see the GNU debugger interface. I can do some things. I can see if there are any functions in this thing, and I can see I have a bunch of functions. We have all the stuff that we have linked to through the standard libraries, and you can see at the bottom we have win, vulnerable, and main. So the key to this exercise is to figure out how we can execute the win function. If I disassemble main, we can see what that does. How many of you know assembly? Okay, yeah, there's someone going like this, and someone is, yeah, I got assembly. So this is basically a simple program. What it does, it calls a couple of functions. It follows the Linux calling convention. And the key thing we can see here is on offset 102. We can see it calls the vulnerable function after it has put a pointer to a buffer that it had run scanf to populate. And that's what happens. That's probably when it says, what's your name? And and then it calls the vulnerable function with that number. Let me put a breakpoint at that location. Where's star? Where's my star? There's my star. So it's 08, 04, 92, F3. So that's where it calls the vulnerable function. So I'm going to set a breakpoint there. Let's look at the vulnerable function. So the vulnerable function, it does a couple of things. It does a string copy to copy a buffer into a buffer. The buffer is from the argument. And then it calls printf using that buffer and prints it out. So that's probably when it prints out the name I did with that thank you for running this binary thing. And return-oriented programming means that I can't execute code that I input, but what I can do is I can overflow the memory, and I can manipulate what this thing points to. So that's the return instruction. The return instruction just tells the program to go to a certain pointer after it's executed, and then increment the program counter. So if I run this program now, let me just set a breakpoint there as well at that return instruction. So let's do 4928C. Is that correct? If I run it, it says, yo, enter my name. My name is still Espen. And now we can see my name is on the top of the stack, and it's about to call the vulnerable function. You can see there the green line. If I continue, I'm now at the return instruction, and you can see at the top of the stack, that's the address back to main, and if I continue, it will exit the program, because it will jump back to main and exit the program. So how can I exploit this? Well, what I could do is I can enter some value, and I'm going to use Perl, sue me. It's fine. Let's do print, let's do A, and let's do that 100 times, I guess. And I will concatenate 4 Bs, and you may ask why B? Because B has the ASCII code 42, and that's the best number. So let's see what happens now. So now on the stack, I have A repeated 100 times, and then I have 4 Bs. If I continue, I can see I didn't manage to overflow anything. I will still return back to main. So I will continue again. So it exited normally. Let me see what happens if I increase this to 110. So now I can see I have 110 A's and 4 B's. If I continue, look at the top of the stack now. It's 0800 and then 4242. So 2 of those B's overflowed into the stack pointer. And if I continue now, I will get a segmentation error because that memory address doesn't exist. So I can see that I missed 2 bytes because I only overwrote two of them. So if I do 112, I can see it's 112 times 4 Bs, and now I can see that the top of the stack is just the 4 Bs. Again, I will get a segmentation error, but now I managed to overwrite all 4 bytes of that return address. So now I just need to figure out what offset win is at, and I can do that. That's the offset. So if I now, instead of my Bs, enter that in, so let's do it's D6, I have to do it reverse because it's little endian, 910408. So it's just that address in blue there. If I do that now, I can see I have the 112 A's and some garbage, that's the same thing I just typed. And if I now look at the return pointer, it now points to win. And if I continue, it will jump not back to main, but back to win, and then exit the program. And then it says, you win. And now that I've developed that exploit, I can run that remotely and do whatever I want to that system. So that is basic wrapping. And you can chain together long chains of these things in order to get what you want to do. So this is the simplest one. Let's do another binary one. Let's do one called Jedi Mind Trick, because this is actually something we can do remotely. And I'm going to show you another tool called Ghidra, which is provided to us by the great people at the NASA. They open sourced it, released it to the public. Why? I don't know, but we thank them. So again, we have this binary called Jedi Mind Trick. If I run that, it says again, enter your name. It's Espen still, and then I say, and then I get a reply saying, hello there, Espen. These are not the vars you're looking for. Okay, let's see what's going on. So let me start by opening Ghidra. So let's go here. It's in my tools folder. So let's do this. Ghidra run. Run, Ghidra, run. So, come on. So this is Ghidra. It's a reverse engineering tool. It can disassemble binaries. So let's do Jedi mind trick. And we open that file with this tool. And the cool thing that it will do some analysis, and then we will get some symbols. Why is everything so incredibly large? Okay, so we can see here we have the functions. And if I find, there we have main. The cool thing about Ghidra is you not only get disassembly, but you also get a decompiled C-like syntax, meaning that it's much easier to reverse engineer. And let's see what's going on. So we have the main. It sets up an array with some flags. These are decoy flags in this case. Then it does a printf, asks what my name is. It uses fgets to read into a 100 or a 256 character buffer. And then it prints that out using printf. And that's that. It does. And we also have a stack canary that checks if you're tampered with the stacks. We can't do the same thing we did in the previous example because it will fail. So anybody see anything wrong with this code? It has one glaring, super vulnerability. And it looks quite benign, but on line 26, you can see that we do printf on name, and what's name? Well, that's the input we read from the buffer. And we do no checking to see what's in that buffer prior to sending it to printf. And printf is a print command that takes in formatted strings. It can do string formatting. And for those of you, you're probably familiar with that in other languages as well, but you have a format specifier, and then you provide an argument that it will try and interpolate into that format. For instance, you have %s means string. But there is no such thing as an argument for what your computer is concerned, because that's a construct that we programmers use. But printf, in essence, what it does when it gets a format specifier, it would just pop the next thing off the stack and try to interpret that as the value. So let's see what happens. So if I run that file, if I give it a format specifier for, let's say, a hexadecimal value, it will just pop the next thing off the stack, which evaluates to 20 or 32. So if I do that as an integer, I will see 32. The cool thing about format specifiers is I can also do the fifth one of the stack as a string. That is a null. And we have this thing running remotely. So if I do this, we have this address where this is currently running remotely. So I can do netcat. That I can't do. What didn't I copy it? Netcat. Let me try and copy again. Okay. Like that. It says enter your name is Espen. Hello there, Espen. And now I will show you another tool. It's called pawn tools. That's a Python library you could use to do reverse engineering. Let me do bat with that so you can see it nicely. So I've written this little program using pawn tools. So I connect to that remote service. I do that 200 times in a loop. And what I do is I get the nth thing off the stack. So nth is I in this case, and I will just see what I get back. I try to evaluate it as a string. And if I run that exploit, it will do that call, and it will leak out the memory of that remote machine. So this is a machine running in Azure. So now I get all those decoy flags, and you will see soon that I'm now into environment variables. So now outside the program space memory of that process, and I'm leaking out the memory of the machine. If I stop this, I can see that the secret I'm looking for was part of the environment variables that I managed to leak out remotely just by using a format specifier. So that is one remote hacking. Any of you do web stuff? JavaScript, TypeScript? Okay, cool. Let's do a web thing then. Let's see. I have my browser. I have this thing. It's a calculator. It looks like a calculator. If I do 8 plus 8, I will get that undefined. Let me try that again. Let's clear it out. It should do 8 plus 8. 8 plus 8. It's hard with this scale in 16, so that worked. I can also type here, so I can do 4 times 4. I can do execute and see that's what's happening. So let me start by getting up my dev tools. Or before, let's do some recon. So there's another tool that's called WhatWeb, where I can just feed this website into it. And it will do some calls to that website, and it will give me back information that I can use to do some exploitation. So let's see what it says. Am I on the network? Come on. Okay, maybe it's not HTTPS, maybe it's HTTP. Or maybe WhatWeb is, there we go. So I can see it's powered by Express, so that means that this is a Node.js app or something like that. And let's see what happens if I do something. Let me bring up DevTools, and let me type something in. Let's do 4 minus 4, and do an exec. I see there's a call. Can I see the call? Yeah, there, evaluate, and it gives me result 0. Now I can start to do stuff. Can I do this? This, for instance, is that possible? I got back math.js result set. So that sounds like a library, right? So let me check math.js out. Math.js and vulnerability. Let's see what happens. We can see that it has a CVE. CVE stands for common vulnerabilities and exploits. And we have this one that's severe, that says creating a type function can result in arbitrary execution. That's probably something we want to check out. So we can see there's some references. Here is a thing that actually does the exploit. And if I read through this, I will find a proof of concept. So for the sake of time, I have saved that already. So let me just show that. So it's this. So what we do, we overwrite the cost function by calling its constructor prototype function and sending in a new thing as its function output, meaning that, and then we immediately invoke that function. So if I send this, since it uses eval in the backend, it will actually evaluate that function. So if I clear the interface, enter that in, I will get back something. It says a buffer. So it says result, and it has an output property with a buffer. So if let's see if we can see what's in that buffer. So what I want output, and it's the second element of that array, and I want to call toString to see if it has a string. So I do the same thing. When I do this, I can list the files on the remote file system. So that's not that's index.js. That's probably the source code for that thing. So let's do that. Let's do that, cat. And let's see if we can see the source code, output, second element of the array, toString. And there we go. Exec. No, didn't work. Let's see. Cat index.js output second element of the array toString. Let's see. Yeah, so here we go. So this is the remote source code of that server running remotely. And here you can also find the flag, which is what I was searching for in this instance. So this is part of that. So I managed to exploit a remote system just because they used a library that had the known vulnerability. And this is what CTFs try to teach you how to do. The takeaways is that, or if you want to get started with these things, there are a bunch of different CTFs that are out there that you can do. In DMB, we usually we do some open ones as well, called Hack the Bank, that I've made. But there's also Hack the Box, which is this platform where you can subscribe and you get weekly challenges. There's also Try Hack Me, Pico CTF. Google has a yearly one that's really, really challenging and really fun. If you want to have some fun at the office over a weekend or something like that, you order some pizzas, get some beers or wine or whatever, download what's known as the OWASP Juice Shop and have like a weekend of hacking CTF, because that's this turnkey Docker thing you can pull down, and it's a web app. It implements all the OWASP top 10 things in different ways, and it's really fun to try and crack. There's also all the different conferences that are hacker-specific, like DEF CON or B-Sides or Black Hat. They have CTFs. What I want you to take away are these things. It's like CTFs, they are really fun, and they teach you how to think like a hacker. They also teach you what tools you can use as a hacker, and that kind of gives you these offensive skills that you can use to test your own systems. Because usually what we do is we have a system, release it, we do an external pen test, but the next time you ship a change to that system, that pen test is actually invalid. And having these skills in your team, being able to continuously test and try and crack your systems, that's beneficial. And I want you all to go back to your solutions and your systems and try to see what happens if you do stupid stuff, because sometimes you get surprised because things may not do what you intended them to do. So put on your hoodies, go out and hack, 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 and have fun. Thank you. So I don't have any social media or anything like that, but if you want to follow me, this is what I look like from behind. Otherwise, find me in the sky bar. That's basically it.